Hello, hello, and welcome back to General Chemistry with Dr. J. We're going to be learning all about physical properties and chemical properties in this video, and also how energy changes are associated with chemical and physical changes. Let's jump right into it. So in the last video, we learned all about what matter is, and we defined it as anything that occupies space and has mass. And then we further subdivided that concept of matter into two categories. Is it a pure substance or a mixture? And then further divided those into two more categories each, into elements and compounds under our pure substance side, and homogeneous and heterogeneous mixtures on our mixture side. And so now we're going to be talking all about what are different properties associated with matter that we may encounter. Now, there's two main types of properties that we think about when we're talking about classifying matter, and those are what are known as either physical properties or chemical properties. Now, these properties are fixed characteristics that can really help us distinguish one substance to another. And so we like to be able to understand what properties are associated with a substance to be able to help classify or distinguish it from something else. Now, physical properties are those properties that tell about the characteristics and the appearance of that substance. This could be things like color, odor, hardness, the physical state that it's found in, being solid, liquid, or gas. So it really helps to describe what this substance looks like and is. Whereas a chemical property, it's going to tell us how that material is going to act or behave when it's combined with another chemical substance. So for instance, when we are reacting acetic acid with sodium bicarbonate or baking soda, we anticipate that there is going to be a chemical reaction that occurs, and there will be some bubbling and fizzing that's created as that sodium acetate is generated, and the carbonic acid is created and actually releases carbon dioxide and water. Now, all matter can undergo different types of changes. There again are two different types of changes that we would be thinking about. There are physical changes, which allow the material to remain its original identity, nothing changes. And then there are chemical changes in which something new will be formed. So for instance, if I took a piece of paper and ripped it up in half, it's still paper. It's just in smaller form, but it's still paper. I haven't created anything new. But if I took a piece of paper and lit it on fire and allowed it to burn, well, we would see that black material being generated, something new being formed. And so that's a key factor to knowing if you have a chemical change occurring. Something new must be formed. Oftentimes, physical changes are reversible, whereas chemical changes are not. So keep that in mind as you think about different changes that you encounter in your day-to-day life. Now, regardless if we're dealing with a physical change or a chemical change, there is an energy change that also is associated with this. Some type of energy must either be gained or released in that substance in order to allow the physical or chemical change to occur. Now, energy by definition is defined as the capacity to do work. And again, all materials are going to have this exchange of energy as they're undergoing some type of change. Now, work is the classical definition is the action of a force applied across a distance. And so as we're taking energy or putting it in a system or taking it away, it's allowing substances to go from solids to liquids or liquids to gases because we're removing and slowing down the particles or speeding them up by placing energy inside or out of the material. There's a lot of different types of energy out there. All matters possess energy. Think of it like money. We're going to get all into this energy idea in chapter 6. There's two main categories of energy that exist. There's kinetic energy and potential energy. And your energy does have the ability to be converted from one form to another. Now, again, regardless if you're undergoing a chemical change or a physical change, there is an exchange of energy as well. So there are different types of energy that exist. One of the main forms is known as kinetic energy. The word kinetic means that there is motion associated with energy. So this is the motion of the atoms, the molecules, or subatomic particles, and can often be thought of as keeping things in motion. One example of kinetic energy is thermal or heat energy. And if you think about it, when you start heating up some water, you start seeing the bubbling occurring. Well, that's those particles, those molecules gaining energy to gain speed to be able to release and go into the gas phase. We also have potential energy. Now, this is the energy that's stored within the matter. And this is really related to the energy associated with the bonds that are within the different compounds or molecules that we're dealing with. Now, these two different types of energy, the kinetic energy or potential energy, can be converted from one form to the other. And so you actually have this idea of the fact that you can go from kinetic energy to potential energy and back but we never create new energy. The total amount of energy that exists in the universe is consistent. And so that idea is known as the law of conservation of energy. Shown here, you can see this diagram that actually represents this interconversion process. At the top, you can see this weight that has some amount of potential energy associated with it. As we put that weight in motion by dropping it off the cliff, that energy is transferred from potential energy to kinetic energy. And then the kinetic energy is transferred back to potential energy once it hits the ground and begins and returns to that stable state. So I hope you guys enjoyed this quick video dealing with physical changes and chemical changes and physical and chemical properties and learning about the energy associated with these changes. Stay tuned for the next video. We'll see you next time.